Hi Brandon, thanks for your question. If we are going to differentiate this expression implicitly, we are going to be using chain rule and product rule. As you can see here, I've written y as y of x just so I can remember that when I differentiate y, I actually need to apply a chain rule to that as well. So let's go ahead and get started. I'm going to apply a chain rule to the left-hand side. I'm going to take the derivative of cosine, which is negative sine, and evaluate that at whatever's on the inside. So that's going to stay at x times y of x squared. I know that looks kind of convoluted, but we will simplify that. And I'm going to multiply that times the derivative on the inside. I know I've got a product rule going on there, so I'm just going to put some brackets in here so that I know that I have to distribute this sign right here. So product rule tells me I take the derivative of the first, which is just x, so the derivative of that would be 1, times the second, so that would be y of x squared, plus the derivative of the second, which would be 2y of x times dy dx. I've got to apply a chain rule there because this is a function of x. And I'm going to multiply that by the first. Let's go ahead and differentiate the other side. Oh, thank God, it's much easier. It's just dy dx. Okay. So I'm going to go ahead and rewrite this so these aren't in terms of y of x anymore. Let's go ahead and do that really quick. Should help simplify things a little. Okay. Now our next goal is going to be to get all of our dy dx terms on the right-hand side. So let's go ahead and distribute this negative sign xy squared to each of these terms in here. So the first term becomes negative y squared times sine of xy squared. The second term will be minus, it looks like we have a 2xy here, so let's go ahead and put that up front. Minus 2xy times sine of xy squared times dy dx, and the right-hand side will stay the same. Let's go ahead and add the 2xy sine xy squared to both sides so that we can get both of these dy dx terms on the same side. So the whole expression turns into something that looks like this. We will have dy dx plus 2xy sine of xy, x times y squared, times dy dx. And we can now factor out these dy dx terms. And the right-hand side will turn into dy dx times 1 plus 2xy times sine of x times y squared. Okay, since our final goal is to get dy dx by itself, because that's what we're solving for, let's go ahead and divide out this whole term. So this very, very ugly looking derivative is going to be negative y squared sine of x times y squared over 1 plus 2xy times sine of x times y squared. And that is your final answer. Thanks again for your question, Brandon, and I look forward to answering more of your questions using Snap Math in the future.